Yep.
Alright, so my speech is going to be about the three current problems that I think are most important when facing with space exploration. And so how many people here want to see space colonization happen in a lifetime? So as you can see, it's like a common cure with most people, especially humanity. So leaders like Elon Musk with SpaceX to use a rocket booster, Jeff Bezos with his Blue Origin, or many sci-fi films have shown this goal. I myself want to see this happen, so I was decided to look into what are some problems facing with space exploration. Obviously there are a lot, but these are the three I will focus on. The budget that NASA is given by the national government of America. Then I will focus on planets going in space and the effects of humans being in space for so long. So let's start off with the budget. So NASA is going to, let's see, MDAK in the balance of 2018, NASA is given 0.4% of the national budget, which is about $444 trillion, and that correlates to just about, that's the least amount of that's a little bit of money compared to any welfare program. So welfare gets more money, the Department of National Defense gets about $303 billion. That's about 30% of the national budget. So NASA is very low. Obviously, space exploration is not a concern of our time, but soon, with Earth depleting its natural resources, this needs to happen. By 2050, I think he said that oil is going to be depleted soon of natural resources. Earth is growing at an expanded rate, and food will soon deplete. So another one is from the journal Magnetohydrodynamics of Plasma Research in 2018 said that NASA gets about 19.1 billion annually. So that, but with recent increase to some of the constellation programs, which is not expected because this given amount of money was set back in 2000. NASA's programs have dropped from 72 planned space missions to 44. So as you see, that drop has been a cause for some of the loss of research. So, and what money makes the world go round, money fuels research. So one of the problems with this loss is how we're going to find ways to simulate planets in space. So, and Jessica Toothman in How Stuff Works in 2018 said that growing machines, which are house plants, need to be responsible for immunity, watering, self-sufficient, and exchange of carbon dioxide and oxygen. And this needs to be a self-made machine, and these are very expensive. So a lot of these little parts will go into making these, and without proper research, we won't be able to see how these work in space. So one of the problems we have is water, and how will we get water to space? Obviously, water is going to be on Earth, so with the transfer of water into space will cost millions of rocket fuel just to deliver it. And then we will put a tank, that water will seem to expire, so often we have to resupply it. And that comes from Young Scientist Journal in 2016, I believe. I forgot the author. Next comes the problem with the effects of being in space for so long. So one of the effects I remember, The Wire 2018 said that Earth is protected by an ozone layer, and this protects us from radiation from the sun. If we have to go in space, which is why astronauts have to protect their suits, and why the satellites are covered in a protective layer of aluminum and other metals, this protects us from subatomic particles flying at light speed, which will cause cancers in humans if it's exposed for too long. I'm pretty sure some of you guys heard of when you go into space, you become weightless as well, and you actually gain height. That's actually a problem because blood circulation is as problem, so you have to keep well with exercise. That's why astronauts keep daily exercise routines for so long, about to 2 hours, so they can keep the blood flowing and they won't have any problems later. But when they get to Earth, they actually shrink down a couple inches. I'm pretty sure some of you heard that with the astronauts. So I went over how the budget is a huge part of research for future research, the planets going into space, how we supply food for ourselves if we were to live in space for so long, and the effects of the effects of being long-term in space on humans. So my suggested theory is to watch The Martian, as is almost scientifically accurate. There are a few troubles with the movie, but I think this is one of the best movies to see if you want to see how scientists want to see quantum computing. Thank you.